Good afternoon, everyone. I hope everyone had a good lunch. So to get started, this presentation is going to be more of a thought-provoking presentation in terms of where we believe the future is heading and what we ourselves as forensic examiners and investigators can do, and what we can look at in terms of potential future obstacles, some current obstacles, what some of the trends are, and also where we may want to have our vendors go in terms of what type of directions we may want them to proceed. So I'm going to provide some potential solutions to some of the problems that we have, but the main objective here is to invoke some thought and future discussions for the industry in general. Clicker work? All right, so maybe my clicker. Oh, there we go. All right, sorry about that. My name is Andrew from Ramin Mapp. I'm the founder of Data Analyzers. We specialize in advanced data recovery, offensive and defensive cybersecurity, and digital forensics. And the presentation essentially is about us as forensic investigators, how we can proceed, how we can try to improve our lives in coping with the ever-increasing amounts of data. So the problem, obviously there's many problems that we do have, but I'm only going to be addressing one. I'm not going to be talking about encryption issues or other issues that we have to deal with at the moment in the future. But the problem that I really want to speak about is the large and vast amount of volume of data that we have that we're needing to process, and the ever-increasing and growing amount of data that we're going to have to deal with and are going to be challenged with in the present as well as in the near future indefinite. Some of the reasons, of course, are hard drives are constantly increasing in size. We're up to about 20 terabytes right now for single drives. SSD drives are getting cheaper and cheaper, it seems, every 6 months. Cloud storage is getting tremendously cheap for consumers. 100 gigs of Google Cloud storage or OneDrive is available for free. Corporations are moving over into the cloud at probably not quite at the predicted amount of speed. And some of the obstacles there have been trust factors, but as we continue to evolve and build out the infrastructure over the internet, that's going to become less and less of a factor, and it's relatively easy to see that cloud is definitely going to be the future, and that the obstacles that we currently have with it are going to be temporary. So we have all this amount of data, increasing amounts of phones that need to be processed, regardless if it's law enforcement or if it's in the corporate world. Cloud storage that's everywhere and is just going to increase in size and capacity. Hard drive storage that is just increasing in size and capacity. So all this data, it's good to have all this data, but from an investigator standpoint, it gets cumbersome and becomes somewhat of an obstacle for us to figure out how to process that large amount of data in an ever-growing set. And in particular, when our clients usually expect us to have it done by tomorrow. So we have to process more data and have to figure out how to do it even faster. So some of the issues here, I won't reiterate too much of it, but I'm pretty sure everyone's going to be familiar with backlogs, queued up processing, things of that nature. So there are two main issues that we have. One of them being processing of data, and the other one being the review of data. So all of the data that we have coming in, how can we figure out how to process this amount of data faster? This is really here a bottleneck that we have. We have more data coming in, but we can't process it fast enough. And then even if we can figure out how to process all of this data, how do we review it? So once we figure out how to process this data, we'll have a poor examiner that's sitting somewhere in the corner and has to now figure out how to sift through 40 terabytes of data. And with the current technology and implementations that we're using, this just becomes quite cumbersome. So we have these two bottlenecks essentially that we've identified that need to be addressed, and solutions need to be presented for these issues. Obviously, here are some of the issues of why constantly we have an increasing amount of new artifacts, which is great if our platform, fill in the blank, whatever you're using, can now process 40 more mobile artifacts or 20 more artifacts for Windows 10. The more artifacts we process, of course, the more resources it takes and the more devices we have, and so on and so on. So let's get down to why can't we process faster. There's basically three areas that we've identified. One being read and write speed issues. While those certainly have improved over the years, right? We went from pretty much IDE and SCSI drives to being with SATA and SAS RAIDs, and now to SSDs, where we certainly have an increase in performance. But overall, in the big picture and the grand spectrum of things, we're still relatively low in terms of IOUts, and it's still a bottleneck that we're faced with. So we're going to talk about that. And a potential solution there is to have multiple storage disks or arrays in parallel. And we're going to get into that in just a moment. The other limitation that we've identified is limited processing power. While there are some solutions out there, for example, Access Data has a distributed processing unit. It's not something that's universally, and so we're going to take a look at that as well. For example, Hadoop being a potential great platform for something like that. And then thirdly, the current way of how we're reviewing data is a bit cumbersome and inefficient, and I believe we really need to figure out a better solution of how we can review and analyze our data and find out how to automate it. Basically going back to that reviewing of data bottleneck here. And the potential solution here is a centralized analysis platform, where we can essentially get all of our data into one platform to review, rather than having a platform for mobile data, having a platform for desktops, having a platform for incident response, and so on and so on. So some of the solutions there, potential solutions, include Splunk and Elasticsearch. Again, these are not the ultimate holy grails of solutions that's going to solve all of your problems, but in terms of architecture and potential avenues for us to move into and entice our commercial vendors to look into, I think those are kind of spot on there. So let's take a look at the first obstacle, reading and writing speed, so our in and outputs. What we can do here is we can look at a parallel clustered file system. Essentially, what that would mean is we'll have multiple RAID systems working on your workstations or forensic servers in your department, and we're clustering those with a parallel file system. Essentially, on top of that, we add a second layer of a file system that is going to allow whatever you put into it to read and write parallel on all of the systems. Some of the parallel file systems include BGFS and Lustre. There are some others out there as well, but these are the most popular ones out there. Generally speaking, you would want to have a RAID configuration, preferably with SSDs, so similar as what your best recommendations are for your current workstations and servers. The RAID 0 will obviously give you the best performance. Of course, the drawback is we'll have no redundancy at all. Alternatively, a RAID 10, a RAID 50, or preferably even a RAID 6 or 60. But the main takeaway here is some type of RAID array where you have high read performance and a medium to high write performance is what we would want. As an example, we can use 3 systems, workstations or servers in your environment. That's what I had set up. And they're all running RAID 5 on SSDs, and the parallel clustered file system essentially sits on top of it. And once you read and write, you're reading and writing parallel essentially to 3 RAID arrays, or if you're having 5 workstations or 10 workstations, whatever the case may be. So this drastically will improve our ability to read and write and address those performance issues there. To go a little bit more into detail with that, we took a look at BGFS, the file system. There's really no hardware requirements or limitations for that. In that sense, it is great in that you can utilize the hardware that you already have in your current work environment. So my goal here was to try to come up with something that can be implemented with systems that you already have in place without having to buy a whole lot of new equipment and develop a new architecture fully from scratch. So all this essentially can run simultaneously to other things that you have going on these systems. With BGFS in this instance, I installed it on 3 workstations, all running Windows 7 and running a VM environment of Ubuntu. BGFS will require some type of a Linux environment to run, so it won't run on Windows. Most common Linux platforms are supported, and it's really designed for performance, so that's really the goal and objective of the file system. There's 4 main components to that: a management service, a metadata service, a storage service, and a client. Any node that you're going to run needs the storage service, and any device or computer that is going to access that storage pool is going to need the client. And the management service and metadata service will run on the first or main system that essentially is the server, and the other ones are the nodes. In my instance, I had the management service, the metadata, a storage service, and a client run on one system, what was the main system, and then the other remaining systems, I installed the storage servers and the client. So this is pretty much what the architecture looks like. It's a picture from BGFS from their website to give you a better idea. And of course, that is scalable to a very high degree. So how do we build something like that? It actually was relatively easy. In my case, I used Ubuntu 16.04, which is running essentially Debian 8. I used multiple virtual machines, and as I already explained, storage service and client on the remaining nodes. Not going to give a full walkthrough and everything, but the main components here were you have to add the repository, then the repository sign, so you'll have to add the signature key to that, and then you'll have to install the services that you want. This would be for the main system, and all remaining systems you would only install either just the storage client or the storage device or the client service. And then you also have an administrative platform, which is GUI driven, which is not mandatory but optional. As you can see here, I've got 3 forensic workstations. Those are the ones that are configured in this storage cluster for the BGFS, and the data is going to be striped and written parallel across them. So that essentially is the first solution that I proposed for dealing with IOUT issues and how we can address performance to really increase our performance and squeeze maximum performance out of that with the hardware that we already have. So continuing to look at why we can't process faster, the second component was really the processing limitation. And so let's get back to that. For the processing component, I have a really unique and very profound solution on how to solve that. I don't think anyone has ever thought about it. It's going to blow your mind. We'll need more of it. We just need more processing power. I'm sure no one's ever thought of it, but that's really what we need to do. Right? So, how are we going to go about that? There is actually a solution. Parallel processing clusters is really ideal to address this type of a situation. And in our situation, what I did, I created a parallel cluster running again on those same 3 workstations, and that can be scaled to an almost infinite amount. And what I used in this particular instance was a program called Beowulf. I'm not sure if anyone's familiar with it or heard of it, but it's been around for over a decade, maybe even close to 2 decades now. So it's not a new product on the market whatsoever. It's predominantly been used in scientific areas, universities, research in those departments. Haven't really seen it being used in the forensic community at all, and so that's why I wanted to include that as a good example. Again, it's free. It is based on Linux, so you will have to use a Linux environment to set that up and be able to process that. The beauty of it is that once you have your Beowulf cluster set up, you're now ready to process your data in parallel, which the more processing nodes you have, of course, the faster you'll be able to process it. And Beowulf is not the only solution to do that, but it was a solution that was easily available for me to implement and utilize, for example, here in this presentation. There are a few disadvantages. One of them, it can be a little bit time consuming to set up and really configure to get the optimal performance out of it. And then the second thing is that programs really have to be written for this parallel environment. In other words, you can't just throw any forensic program that's already been coded in the environment and expect it to run in parallel. So unfortunately, that is not going to work. There is something, the message passing interface, which is utilized in most, if not all, of these parallel processing environments. And in the past, these libraries were available in Fortran, C, C++, but now they're also available in Python. And that's great since a lot of tools in the forensic community are written in Python, especially most of the open source tools. Here is a link to GitHub where you can download the Python MPI if you're having interest in experimenting with that. It's actually not as difficult to implement. So what I did in this example, I used Plaso, and I used some of that code and rewrote it to include the Python MPI for parallel processing. Obviously, I took a very scaled down version of that because I'm not a professional coder and I don't want to become a software developer by trade. So I only used several of the Windows parsers to parse some Windows 7 data. But it was fairly simple to implement as the code is open source and available. So the results that I obtained here, I ran a parser without the MPI and without any parallel processing, essentially how I would run it traditionally on any workstation, and it took 85 minutes to complete. Then the next step, I took the same parser, didn't include any of the MPI or the parallel processing, but threw it onto the parallel file system that's distributed and ran that to see what the performance difference was. And in that case, it took 68 minutes to process. Then I combined both of that, and I took the same 3 workstations that were running the distributed file system, and on top of that, we're running the Beowulf cluster. So at that time, we're now having parallel read and writes to the file system, and we're doing parallel processing, and it came down to 52 minutes. So that's a drastic improvement in terms of performance. I do believe that it can be further optimized to really squeeze better performance out of it, but I'm not a cluster expert. So again, here the main objective was to show proof of concept and show that these are some things that we can implement, and oftentimes without incurring a tremendous amount of cost. Like I mentioned, there's some limitations or some problems, one of them being really the biggest one, that none of the code is written to run in parallel. So it is something, as we go into the future, I do believe parallel processing will become a big part of how our forensic architectures will perform. I feel that it is part of our job to inform our vendors on what we want, rather than it being the other way around. A potential better option than the Beowulf cluster is Hadoop. It's predominantly being used for big data analysis, so it's super fast. It has its own distributed file system, and so it can combine all of that. And I think that would be a real great option in terms of how we could potentially move into the future. But there might actually be an even better solution. So instead of using parallel processing, as I just recommended it, how about a hybrid cloud cluster? Not everyone has probably heard about a hybrid cloud cluster, but essentially what it is, you're having a clustered environment that combines your in-house workstations or servers together with virtual machines in the cloud. The benefit there are that you can scale almost infinitely in terms of processing, and you can keep the cost relatively low. And the way something like this would work, we would have our 3 workstations from the same example running locally in our forensic environment. We would run a parallel clustered processor that would scale up into the cloud, and we can do that essentially on demand, where if we have projects that are increasing in scope but aren't necessarily consistent, where we need to have an enormous amount of processing power available all the time for these peaks that we may encounter, where we have a project that requires a tremendous amount of processing in a very short time period, and we may not have another project like that for another 3 or 6 months, we can utilize the cloud hybrid to basically on demand scale up and add additional processors to a workstation. So in this case, in our example, we were using 3 workstations in a Beowulf cluster. We would be able to scale that by, for example, doubling it by adding 3 Beowulf nodes in the AWS in the Amazon cloud, or by adding 6 clusters into the cloud, and so on. So some of the options in terms of a hybrid cluster, Microsoft actually has a product called HPC Pack, and that's on demand in their Azure cloud. Hadoop also has ready-made solutions available for that. And then Beowulf, there's also some solutions, one of them called Elastic Wolf, if you wanted to take a look at that. So that completes the second part of processing. And the third component literally is, how can we look at our data more effectively? Right, we've now processed all this data, now we have to figure out how to review all of it. We need to figure out how we can analyze it more efficiently, and how we can put it all into context. Again, there are some solutions out there that are heading into that direction, but I believe we're not quite there yet. Again, everything that I've done here has been open source based and Linux based, but I'm not necessarily promoting that to be the go-to-all solution. It's just one way of how it could be resolved or tackled. Elasticsearch and Kibana is what I use for a lot of these type of situations when I have a lot of data that needs to be processed. I've also used Splunk for that. Splunk is a commercial product. Elasticsearch is an open source product, but Splunk does provide you with a certain amount of gigabytes to process every day. So if you wanted to take it for a test spin, Splunk is easier to implement and is pretty much a executable click button solution. Elasticsearch and Kibana is a little bit more cumbersome in terms of getting it set up. To take a quick look at Elasticsearch and Kibana and why it's great is it has great visualization ability. Its indexing is extremely fast. There's lots of plugins available, and it uses NoSQL. So you can create some pretty interesting and creative queries for how to examine and analyze your data. So at that point, you may want to delve a little bit more into how to write basic search strings and search commands in NoSQL, which is almost the same as doing it with SQL or MySQL, if you have any experience in that. And then the other areas where it really excels is the searches. You can do fuzzy searching, you can do a lot of filtering, you can run a lot of scripts. There's a lot of predefined scripts. You can create scripts relatively easy, and there's also some commercial components available for machine learning, which can really help you when you're looking for abnormalities as an example. This is what the Kibana interface looks like. This essentially sits on top of Elasticsearch and is basically your analytics platform and a greater GUI that allows you really to slice and dice the data and really get into looking at some of the data patterns. So again, some of the benefits are machine learning ability, the ability to automate report writings, the ability to really ingest any type of logs, metadata, and artifacts. You can write your own parsers relatively quickly and easily, and you can really process and review all of your data in one platform, regardless if it's mobile data, if it's incident response logs from a firewall or some type of threat agent, or if it's cloud artifacts. The other thing I wanted to look at is e-discovery. The e-discovery industry has really made some significant progress over the years, and two of the areas where they've really excelled is in TAR, which is technology assisted review, and predictive coding. In both of those instances, they're using machine learning to really assist in automating and filtering to data to really get to what's relevant and speed up the process when terabytes and terabytes of data are being reviewed. So I think that we really can learn from the e-discovery industry in terms of how well they have started to adapt to newer technologies and machine learning. And I know that we've made some progress in those areas, but I really believe that there's a lot that still can be done to really help us in making our lives easier and thus become more efficient. Some examples are pattern-based recognition, image recognition. I know some vendors are doing some image recognitions. What Google's been doing with that is really phenomenal and impressive. Abnormality detection, cloud natural language. If you're not familiar with it, take a look at that. That's quite impressive and interesting, especially if you if you're looking at potentially profiling a victim. And there's so many other potential solutions out there where machine learning can really be applied. So to summarize the whole thing, what we really wanted to focus on is how to improve speed, how can we process our data faster. In this instance, my recommendation is a distributed file system for increasing the read and writes, a distributed clustered parallel processing so that we can process more data and do it faster. A centralized review platform rather than having multiple platforms, and a centralized review platform that has analytics built into it where we can put things into context. And then more aggressive use of machine learning and predictive coding and automation in these particular areas. Do we have any questions? No questions? All right. As a last thing, one of my employees actually bought me this book, and I didn't get around to reading it until actually on the plane. It's called The New Digital Age. It's by Eric Schmidt and Jared Cohen. Eric Schmidt was former CEO of Google, and Jared Cohen was director of Google Ideas. So this is a quite interesting book. It doesn't cover any digital forensics, but it speaks about the future in terms of how they see it, what they are predicting that's going to happen here in the near future. And I think it's a very interesting read if anyone has an interest in it. It certainly will be thought-provoking as how this may affect our industry and what we're currently doing. If there are no more questions, thank you again. Oh, yes, sir?
Is Plasso thinking about incorporating Beowulf clusters or anything else? I mean,
pardon me?
is Plasso considering incorporating some of the API stuff to do clustering, or is this just a thought experiment on your side more than anything?
It was just an experiment on my side. I actually did send an email to one of the developers a few days ago, but I haven't heard back yet. So I'm not sure if they are, but it would be really, really nice if they will. I will definitely make another attempt on following up on that. The great thing on Plasso is you do have multiple forks, so even when the main developers may not want to proceed with that, what happens oftentimes is another fork spans off and a subgroup of the community thinks it's a great idea and they'll implement it on a subversion of the Plasso fork. But
there's a presentation about it an hour from now. So.
There is, yes. I'm not sure if it's a developer or not, but we certainly can ask him. Any other questions?